Hi, notes for today are on Chapter 4, Section 3, Adding and Subtracting Mixed Numbers, and really want to break this up into three different parts. So there'll probably be three different videos, maybe I'll have them all combined in one of them. But the first one, this one I want to just look at initially, how do you switch from a mixed number to an improper fraction, and how do you switch from a improper fraction to a mixed number. But going to start with Roman numeral 1 and just say terms, just in case either of those are unclear with exactly what they are. So for the terms, I'm going to start out with my improper fraction. So improper fraction, and in an earlier section we talked about the top of a fraction being the numerator, the bottom of a fraction being the denominator. Well, an improper fraction is where the numerator, the top, so the numerator is larger than the denominator. So any example of that could just be any fraction where the number on top is larger than the number on the bottom. So 7/4 would be an example of an improper fraction, or 8 over 3, 8/3, something like that. So that's going to be my improper fraction. A mixed number is going to be where you have a number in front of the fraction. So an example of that perhaps would be like 2 3/5 or something like that. So a mixed number is a number and a fraction. And the example, not sure exactly what I said before, but 2 5/8, maybe something like that. So the fraction itself is going to not be improper. It's going to be a one where the numerator is smaller than the denominator. But so this main part here I want to look at is, well, how do I take improper fraction like 7 over 4, how do I take and change that to 1 3/4? And how do I take a number like 2 5/8 and change that to 21 over 8? So that's going to be my Roman numeral 2 and my Roman numeral 3. So Roman numeral 2 then here, I'm going to go with that first one, so an improper to a mixed. So how do I go from an improper fraction to a mixed number? And with that, I'll maybe just do a couple examples, and don't really have anything to write about this as much as just to do some. So my first one is going to be a 10 over 7. So if I have 10/7, well, if you were to do the division there, if you were to take a 10 and divide it by 7, well, 7 goes into 10 one time, and when you subtract that, you have 3 left. So as you learn long division, I believe, I haven't taught that, but they teach you that it's 1 remainder 3. So the 1 is going to be the number in front of the fraction, and we had these 3 that were left. Well, it's technically 3 out of the 7 are left. It's kind of like this 1 here took 7 of the 10 away, and then 3 of the 10 are left, so we have 3 of the 7s left. And that's kind of how I look at them. So as opposed to doing like this long division every time, I look at, well, how many times does 7 go into 10? And 7 went into 10 once, that's where the 1 comes from. That takes 7 of my 10 away, leaving 3 left, so I have 3 over 7. If we take and apply that to this new one, to 14 over 4, well, you start by saying, well, how many times does 4 evenly go into 14? So if you do your multiples of 4, you have 4, 8, 12, and then 16. So it only goes into it evenly 3 times. So if I take and put my 3 out in front, well, that takes 12 of my 14 away. So then I have 2 of my 14 left, so 3 2/4. But best to reduce the fraction whenever possible. So it'd be better to say 3 1/2. Because once we have this 2 and this 4, they're both even. So we can divide by 2, and that gives me my 1 and my 2. Maybe do another example. Book could try to make it a little bit trickier by doing something like this, 15 over 3. Technically it's easier, but because it's different it tends to mess some people up. But 3 goes into 15 how many times? You could count it on your fingers. You could try doing 15 divided by 3 in your head. But it's going to be 5. And what's different here is 3 goes into 15 evenly. So if you do your multiples of 3, you have 3, 6, 9, 12, 15. So then when you do this 15 divided by 3, it's kind of like up here you'd have a remainder of 0. So you could view it as though it's 5 0/3, but we're not going to write it that way. We're just going to say it's 5. And maybe the last one would be a 32 divided by 6. And so how many times does 6 go into 32? If you do your multiples of 6, you get 30 and then 36. So 30 divided by 6 gives me 5. Then that would take 30 of my 32 away, leaving me 2 left. So I'd have 5 and 2/6. Because they're both even, we can reduce them down to 5 and 1/3. And if I've kind of lost you on some of those, maybe just make this comment at the end. If you like looking at them like this original fraction, if you would go and do your 32 divided by 6 long division wise, that's going to end up giving us a result of 5 remainder 2, and the 5 just is the number in front, and the 2 is going to end up being the numerator before we reduce it. If I did that same thing here, 14 divided by 4, that would end up giving me a 3 remainder 2, and the 3 again is the number in front, and then the 2 is the numerator. So you could go back and kind of do that extra step if you'd find that helpful, but if you don't need that, it'll make it a little bit faster. My next one that I want to hit in this video is going to be, well, how do we do that in the opposite direction? So Roman numeral 3, mixed number, so I'm going to say mixed to improper. And it's kind of like doing that last process but backwards. And again, I didn't really come up with a how do I write out steps or an explanation. Thought it might just be best to do several examples, and then that would kind of work. 2 3/5 with that. So for that, here's kind of the way that I believe the book talked about it, is that if you have this 2, and we know that our denominator here is 5, maybe I should start by saying, well, 2 3/5 is kind of like 2 plus 3/5. So I'm going to have my 3/5 over here. Well, how could we write 2 with that same denominator of a 5? And what divided by 5 is going to give me 2? And it would be 10. Because 1 would be 5 over 5. So then 10 over 5 would be 2, or just 10 divided by 5 is 2. But if you look at it this way, now if you want to add the fractions, you have a common denominator, so that just stays the same. And we have 10 plus 3 in the numerator, so 13 over 5. So 2 3/5 equals this 13 over 5. If I were to do one more like that, we'll say 3 5/8. Now I'm going to show actually how I kind of do them in my head next, but I want to kind of try to prove a point doing one more this way. That now if we were to have our 5/8 over here, and say, okay, I want to have that common denominator so I can combine my numerators in the end. Well, 3, that's going to be what divided by 8? And 8 over 8 would be 1, 16 over 8 would be 2, just doing multiples of 8 up here, so 8, 16. 24 divided by 8 would be 3. So now I could say 24 plus 5 is 29. I can add those because I have a common denominator of 8. So 3 5/8 is going to equal 29 over 8. Okay, so that's kind of the process, or maybe even the why does it work. The faster way is this. My numerator is really going to be 2 times 5 plus 3. So 2 times 5 is 10, plus 3, 13. My numerator is going to be 3 times 8, 24, plus the 5. So you can maybe kind of view it as like a, I don't know, a C drawn starting at the bottom or something, but 3 times 8 plus 5 gives me 24 plus 5, 29 over 8. So that's a way that you could kind of do that as a shortcut, but if that doesn't make sense, then you do it the old school way, you kind of do it the long way. But the shortcut then would be 4 times 2 gives me 8, and I have one more, so my final answer is going to be a 9 over 2. If you want to look at, well, how do we get that? Well, we have our 1/2, and how many over 2 is going to give me 4? Well, I'd have to do 4 multiples of 2, so 2, 4, 6, 8. 8 over 2 is equal to 4, so then 8 plus 1 gives me the 9 over 2. Maybe one more if you need it. If you don't, well, you can just skip this one. But 8 and 5/6, so 8 times 6 is going to be 48 plus 5, so we should end up with 53/6. And if you want to do it the long way, we have our 6/5, and here, oops, thinking ahead. So I have 6 there for denominator. So 1/6 is going to equal 8. Well, that's going to end up being 6 times 8. So 48. And then we add our fractions together. 48 and 5 is 53. Keep our common denominator of 6. So that's the how do you go from improper to mixed and mixed to improper fractions.